So, as we have the Blackman-Tukey spectral estimator, the other researchers they became inquisitive about its development, that Blackman-Tukey made such a huge contribution, and in scientific world actually the progress goes through review. They started reviewing the results proposed by Blackman-Tukey, which solves all the problem of periodogram, at least at that moment. So was thought by Blackman-Tukey and other researchers. So, they started the review and they came up with number of criticisms of Blackman-Tukey. So, let us look at them. So, the first thing they found that new estimator does not guarantee non-negative spectral estimate. At times that PSD value can be negative, and that is an absolute no. We cannot explain at certain frequency the energy is negative. Physically we cannot explain that situation. So, it becomes very difficult to accept that kind of estimator. Okay. And then they go forward, the researchers they are not criticizing just to defame Blackman-Tukey, they want to get a better actually estimator to improve the situation. So, they try to explain that why it is happening. Okay. So, they search for that how it may give negative values, and in that search they find that here the estimator what we have taken as Blackman-Tukey estimator that is using a window function along with the autocorrelation estimate before taking the multiplying with a window before taking the Fourier transform. So, in the frequency domain it can be taken as the convolution with the real periodogram. Mind it, this is periodogram, this is not the true PSD. With that, this new window or spectrum of the window is coming into picture. So, now with that what is the effect? This WF, that is the spectrum of the window, it can be negative enough to cause the estimate negative. Actually, this is the main culprit, that it can, if it is negative, it can pull down that convolution result to negative. Okay. So, we need to first take care of the window function, we need to be careful about the choice of window. So, let us see what they have suggested. To ensure positive result, the lag window should have a non-negative Fourier transform, or equivalently Wk must be, that means in the time domain that window must be a positive semi-definite sequence. Okay. Semi-definite means the value could be 0. If we tell positive sequence, that means that the result should be always positive, it cannot be even 0. Okay. So, that is the new thing we get, and fortunately there are some windows which can give positive semi-definite sequence, that Bartlett window and Parsons window, they satisfy this condition. Okay. they satisfy this condition. So, we are relieved that some of these windows they are good enough that we can get the better estimate. However, the problem can come from other sides also. See, we are using unbiased autocorrelation estimator, because we are using the windowed version of the estimated autocorrelation which is unbiased. These can also cause negative estimates. Okay. So, we cannot guarantee actually that these estimates would be always positive. Okay. So, all the development that is done, hopefully it will give us an estimate, but we cannot give any guarantee on that. So, still unbiased estimate can give non-negative estimates. So, now let us look back that W k equal to 1. If we look at the initial one, that window, that a rectangular window, as we are going back, we can come back to the original periodogram estimate. So, Blackman 2K, it is giving us some flexibility. By some choice of window, we can go back to the original periodogram from where he started, he wanted to improve, and from there we can do something better by a better choice of window. At best, what we can tell that Blackman 2K spectral estimator is a smeared version of the true PSD. Smeared version means it is convolved with that spectrum of a window. So, it is called smeared version. Okay. It has the word smeared, that has a negative connotation, because the other researchers they have criticized. So, they have used this term. So, if you do not like it, you may tell that it is smooth version of true PSD. Okay. But the fact remains the same, that we are using a smoothing function and we are convolving with the true PSD that we get, we are supposed to get. First of all, it is taking the original periodogram estimator, then using some other window. So, twice it is getting smoothed or smeared, whatever way you would like to take it. So, this is the expression we get, that combining the two, the different estimates, that we get a smeared version or smooth version of the original PSD. Okay. So, that is the evaluation we get about the Blackman 2K estimator. So, let us look at the variance of it. The variance under this assumption that the PSD is smooth over the interval is equal to the bandwidth of the main lobe of the spectral window. That means, if the M is high, the main lobe bandwidth is low, which is good for the frequency resolution, but it gives us more variation. Okay. So, we get some expression for the variance also. What we get, that it is proportional to that true PSD. In fact, that was the criticism for the original periodogram, that variance is as big as the mean, we get some term with that, that is the bonus. We get something in the numerator, we get sum of the windows from minus m to m, and below we get n. So, by choosing m lower than n, we can reduce this term. Also, by appropriate choice of these window values, we can reduce it further. So, the variance would be less than the original periodogram estimator, that much certainly we can say, and we can have a control over the variance. Okay. So, however, there is a trade off between the bias and the variance. When we try to reduce the variance, what we can do? We can reduce the value of m, that will reduce the variance, but increase the bias. Okay. So, that we need to keep in mind, that we cannot get good result for both of them. Okay. So, there should be some compromise in such case, and empirically what the people have found, that if we take m is 1/5 of the length of the data, it usually gives a good compromise between these two, because some of the standard window, for example, Bartlett window, if we take, for that at that lag, that m equal to n by 5, variance has a good decrease by a factor of 7.5. It is reduced, and we get it in this way, that it becomes 1.75 times of the estimate, and there would be of course some increase in bias, but as the variance has reduced, that gives us some better estimates, and we get that we cannot solve both or improve both at the same time, bias and the variance, but we can tune them to get as best as possible result. With that, we actually complete our discussion about the Blackman-Tukey spectral estimator. Thank you.